Thank you. So I'm going to talk about a new OHDSI R package today called CohortConstructor. So I think as people will have noticed as the morning's gone on, and even some of the previous presentations, cohorts are a key building block in research studies where we define some people who fulfill some criteria for some amount of time. And we already have well-established OHDSI tools for defining cohorts. So we have Atlas, that I'm sure many in the room are familiar with, and also Caper. And behind the scenes, you have the CohortConstructor engine that's doing a lot of the work. And these allow us to define cohorts and can be instantiated in a database and also can be stored in a library for future reuse. However, there are some limitations in the current approach for certain types of studies. So in particular, in certain circumstances, we have computational challenges when making many cohorts. And sometimes we might want to have very bespoke cohort logic that we might not be able to do with the current tools. So that was the motivation for building this package. So first, I'm just going to talk about how it can help make many cohorts at the same time. So in the typical approach to making cohorts, we define them independently and instantiate them sequentially. So we might have a cohort of asthma, and then we might have another cohort of COPD that we then create, one for diabetes, one for paracetamol, one for warfarin. So CohortConstructor works slightly differently in that it builds cohorts by domain instead of by definition. So say those first three cohorts were defined based on the condition occurrence table, so codes in the condition occurrence table, they would all be built at the same time together. And similarly for our drugs, they would also be built simultaneously. So I've taken a risk, hopefully this will work, to see what this looks like in practice. So here we connect to the Eunomia data set. We're going to get some drug ingredient codes. So here we've got 6 drug ingredients that we want to make cohorts for. And then we start with CohortConstructor making a concept cohort. So as you can see, this will build all 6 together because they're all based on the drug domain. And after making these cohorts, you'll have the settings associated with creating them, such as the CDM version, the vocabulary version, and also other attributes like the cohort count. CohortConstructor also kind of facilitates making going from one cohort to many. So we might often in studies build many cohorts that only vary slightly. So we might say have an asthma cohort where we have a requirement of 0 prior days observation and age under 18. We might have another cohort definition that's the only thing we change is that people are required to be 18 or over. And then we might have a couple of sensitivity cohorts where we add the requirement of 365 days prior observation. So with CohortConstructor, it encourages building a base cohort from which these subsequent study cohorts can be derived. So in this approach, you'd build your asthma base cohort, and then you'd apply the requirements about prior observations, and you get 2 cohorts back. And then you'd apply the age criteria, you get 4 cohorts back, and you'd end up in the same place as before. Again, we can see what this looks like. So working with those same 6 drug cohorts we started with, we can just add a requirement about 2 prior observations. This will give us 12 cohorts back, where they vary based on that requirement. We can then also apply 2 requirements about age, and then we'll get to 24 cohorts where we have both that variation in prior observation requirements and age. And again, we'll track the settings associated with those cohorts and the counts of them. So under this approach, you often end up with programmatic pipelines to build these cohorts. So what that needs is lots of utility functions to kind of facilitate doing kind of whatever you can think of to your cohort. These functions include adding or subtracting days to cohort entry and exit, creating cohorts based on age. So for example, creating a cohort of people that enter on their 18th birthday, resetting entry and exit to the cohort based on some external date variables you might have, requiring subjects are present in or absent from another cohort or a table in the OMOP CDM in some time window, taking random samples of cohorts, and also persisting cohort entry across multiple observation periods, and that'll be in the next release. So what might this look like? So here, for example, we define a hip fracture. We start with the exit at the same day as the event. We then reset that to be 180 days afterwards. We require that it's a first entry, and then just to show how it looks like, we take a sample of the cohort, so the maximum cohort will have at most 100 people. Again, we'll have the settings and counts associated with our cohorts we create. As part of the process of building this package, we're working on some benchmarking. It's still very much a work in progress. To start with, we've taken 9 cohorts from the OHDSI phenotype library. Firstly, we've created these cohorts using CohortConstructor and then also with CohortConstructor. If it was on the dotted line, that would mean they take exactly the same time. As you can see in these test databases, CohortConstructor is actually a bit slower, which maybe I shouldn't have shown this one. But once we start working with real data, we see some differences. So here we have one data set from Estonia with around 400,000 people, and CPRD Aurum from the UK with close to 50 million people. Here we're no longer looking at minutes on the axis, but hours, and it's on the log scale. So we can see, in general, making a single cohort takes about the same amount of time, except for one of the cohorts we found that it was taking nearly 100 hours to make using current tools, and with CohortConstructor it was done in an hour. So that's it. I've tried to sell it with that last example. I'm sure others could be found. Yeah, so just to wrap up, here's some more information. So there's a website to go with the package. There's a GitHub link to OHDSI. There's also benchmarking code, so it'd be great if data partners in the room wanted to give it a go and give some feedback. And if people have examples of cohorts they want to build, they could try it out. And just lastly, to thank the other contributors to the package who've done a lot of the work, and also the data partners that have run the benchmarking so far. And I think with that, I'll just say thank you.